Good afternoon, everyone, and thank you for coming to our theme session, or symposium as it's called here, on data science methods for code-speech research, for code-speech gesture research.
I was saying that around the world in all kinds of different sciences, people share data, epidemiology, materials science, you name it. But for those of us who study multimodal communication and human subjects, it's often the case that we are blocked from sharing our data exactly because of privacy reasons. We have to anonymize, right? We'd like to be able to share our data with other researchers, to tag it, to replicate our research. We would like to be able to use the data as prompts when we're doing behavioral experiments. Now, in one of my careers, I do a lot of experiments in behavioral economics, and we share all that data, 2.5 hours of data. The articles say data set available on request, or it's posted in the Harvard data bank or something like that, right? Wouldn't know how not to do that. We're allowed to do that by an IRB exactly because we know how to de-identify text. We block out the emails, the names, the everything else that's in the comma separated value file. But how do you do that with an audio visual recording? There is no protocol for this, much less a technology. But now everything has changed. So Red Hen runs Google Summer of Code. About 2 years ago, 2.5 years ago, I came up with a plan for de-identifying audio-visual data so that it could be shared, potentially. And my first attempts didn't work at all. It was kind of hilarious. I can go into that. But for Google Summer of Code 2021, I put up as a project coding some of these ideas. We got a number of proposals, one from Yash Kashbaga. We selected him. He spent 12 weeks coding. And now we have the Red Hen anonymizer. It's on our GitHub. You can go to markturner.org or to redhenlab.org. You can download it. You can use it with a few little extra points that I would have to say if you want the technical details. On speech, we use SOX effects. There are 61 different SOX effects with many different values, but even if there are only 20 and each had only 3 values, that's, many billions of possibilities. So you can't reverse the audio to get the original. You can make a robotic voice, you can do all kinds of things, you'll see. For the face, one of the first things you can do is swap the face. There are lots of computer-generated faces that look really good, and they don't belong to anybody. There are hundreds, thousands of these. And you can swap the face with one of these computer-generated faces, and it preserves many of the key points of the face. Another thing you can do is block out the face by just omitting the face. I'll show you that one. And the last thing you can do is use a body pose key point computational system like OpenPose to map the original onto a skeleton, as it were, a skeleton of key points, and lose the entire original video, in which case all you see is the skeleton. And I will show you that one. Here's Red Hen. That's Yash Kashbaga, who did most of the coding with a lot of mentors. Here are computer-generated faces. Look pretty good, huh? I wish I had some of these faces, right? Now here's any video, and I mean any video. It doesn't have to be pre-processed. You don't have to get it from any. I mean, it doesn't matter. You could have early film. You could have home movies. Okay, so any video.
He has in the channel, and his remote balance is my balance. So
you swap his face. Okay, You just pick any face, any computer-generated face, and
he has in the channel, and his remote balance is my balance. So in every payment channel, there's two.
de-identification. Now, for research purposes, there might be many reasons that you would find one of these de-identified things suboptimal. Maybe it changed the features in the voice that were exactly the ones that you wanted to study. So you wouldn't change those in the Red Hen anonymizer, you'd change them. But I'm not talking about all those other research questions. I'm just talking about de-identification so you can get something through the IRB so you can share it, right? That's all we're talking about today. So here's another video.
The word pandemic may sound like a scary word, but it really has a very simple meaning. It means there is a newly...
Any face?
The word pandemic may sound like a scary word, but it really has a very...
This is a robotic voice.
It means there
right?
is a newly...
Okay, now the point is, any de-identification, textual or audiovisual is bad because you're losing data, right? But at least you get to share it. So you have to make judicious, tactical interventions to figure out how much de-identification you do to get it through the IRB, but not lose the things you want to study. Here is you block out the face, and we do it with very low confidence. So anything that it thinks is the video might be a face, it blocks. It will block pictures, little decorations that might look like a vase. It just blocks them out. And you get to pick the shape.
Back then, scandals among powerful people were extremely common.
That's a lab assistant. Thank you, Daniel. Now, you've seen this video before. Here's OpenPose.
He has in the channel, and his remote balance is my balance. So in every payment channel, there's two balances.
You don't have to prepare anything. You can take any video and the system will run on this and do it. No sensor, no motions, no special, anything. You just run this through, right? Multiple people, all kinds of stuff. Learn about OpenPose. Now you can just drop out all of the video.
He has in the channel, and his remote balance is my balance. So in every payment channel, there's two balances. Think of it as...
Now, I know this looks like skeletons. The skeleton is just an illusion for you. In fact, what these things do is just turn the video into vectors. It's just numbers, which means total de-identification. Like in the numbers. Thing two, you can search numbers with wonderful Unix calls like, grep and awk and find and things like that. So if you can characterize a gesture by its numbers, then you can search for it using regex or something like that. So for example, if you want to know if somebody is looking straight at you, well, the line segment between their pupils and the line of the nose should be perpendicular, and the nose line should intersect the line segment of the pupils, should bisect it, right? Yeah, it's just numbers. This is all going to be in print. We submitted a 6,000 word article, the Linguistic Vanguard. We got a very positive review. They asked for good modifications. We've done those. I posted them. I'll be really surprised if it's not published. You can write to Mark Turner. Go to markturner.org. You'll get all the coordinates for the preprint, which will have all the links to everything. And I want to say also that this is actually the hardest part of the project. Since September, I have been working with the Case Western Reserve University internal review board in order to get guidance on what kinds of proposals using the Red Hen anonymizer they would accept that would allow you to share data. Now, I have to say, they really had a hard time wrapping their head around this. It submitted in September. It's now July. I believe that I'm a millimeter away from having a 2,000 word organized final document from them on guidelines for meeting the revised common rule in your proposal to an IRB so that you could then share data, keep it, open it back up for other questions, give it to other people, make open data sets, thank you very much for your attention. Next is Greg.
I'm wondering, so there's always this sort of like catch-up game of anonymization where like you try to anonymize data and then also the mechanisms to reverse.
Yeah.
Well, like follow.
That's absolutely crucial. All 100% of our attention is on non-reversibility, right? Okay, so let me say that all we want to meet is the revised common rule, and the revised common rule's requirement is that the data be in such a form that they cannot be readily de-identified. If Mossad or the NSA or somebody else wants to do this, they're going to be able to do it. They'll just break into your house and steal the original anyway. So we're not at that level, right? And there might be some stuff you just decide is too risky, too touchy, too emotional. You don't want to do it anyway, right? So we're not trying to boil the ocean. 1% progress would already be a lot of progress because listen, we can feed that data to machine learning, right? Now, if you read the paper, it will point out that there are certain kinds of things that just in principle, you're not going to be able to get back to the original on. So a vocoder, which is the robotic voice, or vocoding is a particular thing, does not feed the input in to get the output. It samples from it and does it in certain ways. So there's no way to reverse back to get the original. And on the visual, something like just turning into key points wipes out the entire visual field. Now I have to say, if you happen to be the mother of 5 children and you know the recording is one of these 5 children, it doesn't matter if you're looking at a robot gesturing, you're going to be able to pick it out. If you know that this is somebody in the White House, you're going to be able, that's not what we're talking about. We're talking about, you don't know the university where this was recorded. Nobody's wearing a t-shirt with their name. Everything's locked in the usual sorts of ways, plus which the only thing you're getting is the skeleton, okay? So the question is, under what conditions, not what I would think, I don't count. The question is, under what conditions would your IRB say, yeah, you record this data, you put it in this form, not the original, but this form, then you can give it to your extra research group that's aligned with you that's down in Duke. And then Bob's your uncle. Notice, by the way, one particular thing. If for machine learning, if you're just showing this to a computer, not to a human being, does anybody really care if you're showing the data to a computer? And the computer comes up with an algorithm that measures various kinds of things. It's not even presenting the original data or the revised data anyway. It's presenting an app that recognizes palm out, open hand, right? And then you can use that on any kind of data, right? So this is exactly the right question. It's the last one I'll answer. Go ahead.
Yes, I should have said time for half a question. Maybe.
There you go. All right. Yeah. Okay.
We'll just try this one. So continuing the idea of open data sets and also how to use these things for baseline machine learning. Okay, we did this. Swadhish Yana is actually on Zoom here. He's not here today. He's a Google Summer of Code student who did that last year. Greg Woodin is here and he's going to talk in a minute. Yao Tong can't be here either today. And we also had help from Liz Mahoney at Case Western Reserve University, who did a capstone project on the open data set. So we're going to have 3 points today: using public repositories to create open data sets, detailed annotations with the Red Hen interview gesture collection, and then using open data sets for machine learning with a baseline example. This is not complicated machine learning. This is relatively straightforward summer project thing. But first of all, your part, Greg.
Yep, thank you. So this is the section that I'm going to be talking about, then I'll hand over to Peter. So yeah, so I'm going to be talking about how to create open data sets from publicly available repositories. So it's pretty self-explanatory, but open data sets, these are data sets that are openly accessible to anyone that wants to view them and use them. And Mark has already touched upon this, but the whole open science movement is important from the perspective of reproducibility. So things are fully transparent. So, people can look at your data, they can see if they agree with the analysis choices that you made or the coding decisions. They can also perform their own analyses of your data as well. And so there are reduced costs in terms of time and money, because if there is already a data set that you can use, then you don't have to expend either of those things collecting your own data. And so for all of those reasons, open data sets can be a major driving force of scientific progress, which is why it's unfortunate that this trend hasn't reached all areas of humanities. It's not as widespread as perhaps it should be. I mean, obviously there are obstacles that Mark has talked about, but we're all trying to move towards more open access, more transparency and things like that. So just to give you an example of a study in which my collaborators and I created an open data set. This was a study in which we're interested in when they use metaphor that they were using in their speech. And to do this, we used a website called the TV News Archive. So this is accessible to anyone with an internet connection. There are over 2.3 million videos on this website. So, it's a massive repository that's just ripe for gesture research. And all of the videos are closed captioned. So we're able to search for the phrase that we're interested in. So these are the results for tiny number. You get back a list of all these different videos and you can watch them and see how people gesture when they use these different phrases. And each of the videos is associated with a URL. So anyone with this URL can watch this video. So you can create an open data set using these URLs. And so we essentially used R to scrape the URLs from the TV News Archive and take a sample because there were far too many to manually annotate. So you can see we've got it's quite small, we've got the URLs in one column, and then we've got various other columns that code for other features of these videos or these gestures. So there's like hands moving, whether they move their hand when they use the phrase, which hand, whether they use the left hand, right hand, or both. This probably looks a bit different from maybe some of the gesture analyses that you might be used to, with like timestamps and things like that. But that was the method that we chose, we went with for this study. So you can have a look to see if you agree with the decisions that we made. You can watch the videos, and you can also do your own analyses of these videos as well. And here is an example of one of the videos.
A tiny number of people.
So yeah, you can see the clear tiny number gesture there. And this data set is stored at the Open Science Framework repository. So this is, this is available for anyone. This is openly accessible. And the OSF repo also contains our R script as well. So this is the script that we used to get all of the URLs. So you can edit the script to search for whatever phrases you're interested in as well. So we've made an effort to really share everything that we use. And, as long as you give credit where it's due, then, all of this is free for anyone to use. And we encourage you to use it because all in the interest of open science and scientific progress.
Thanks, Greg. I'd like to talk about another open data project that we've been working about that's based on NewsScape, and Mark mentioned Red Hen Lab, the distributed Red Hen Lab. So NewsScape is a collection similar to the TV News Archive that you saw there, but it's hosted at UCLA in the Communication Studies Department, mainly run by Francis Dean there and the library. And the advantage for us is that we actually can get access to the files and we can process them linguistically, run part of speech tagging on them and things like that, that we can't do with the TV News Archive. And Again, it subtitles as text, recent ones even with commercial detection. So you can say exclude commercials, for instance. And you can download, we have downloaded transcripts for some shows. We have OCR on the on-screen text, optical character recognition. And it's basically the basis of much of the research done by the distributed letter and Rab. And Mark will tell you more than you ever wanted to know about this if you ask him. So why is this whole thing important? I think Greg mentioned it already, so I can keep it short. Manual annotation is extremely time consuming. You all are witnesses to that, I think. And so what we have here is interview segments from the Ellen DeGeneres show, roughly 10 minutes each, that were annotated in Elan as part of 2 PhD projects at the Vrije Universiteit Amsterdam under Alan Chenke's supervision. So that's Sue Wu, who did roughly 10 videos with very detailed annotations. And then we had Yao Tong, who's, I think, on the verge of submitting her PhD, or maybe she has already, with 30 videos, but less detailed. So one of the really detailed ones by Sue Wu looks like this, and it's all Ellen DeGeneres videos.
Mickey Mouse doesn't come out that often, just so you know. You don't walk around Disney, he only hangs out on Main Street. He's not like running around accessible. He's a celebrity.
Okay, so you see that we have handedness, gesture phases, handedness, hand shape, orientation, location, movement type, movement direction. All these are annotated for all these gestures. This is a treasure trove, and these kind of treasure troves need to be shared with the community, I think. And the problem is we can't share. This is copyrighted data, so we can't actually give out that video. And the working around that, we have multiple ways. I mean, one is you become a member of Red Hen Lab and borrow this, like you lend this video, they lend it to you. What the exact legal repercussions are there has never been tried in front of a court, but it seems to be working. I think, not for the digital age, I think. No, it was in the libraries allowed to lend out copies. Yeah, what is a copy? I mean, how do you lend that in the digital age? Well, I don't want to go there. So, but we have 2 other approaches to make this really open. And one is, we find these interviews on YouTube because most of them are actually on YouTube. And so there's EllenTube and YouTube and you name it. And you basically set up instructions on how to download them and what time offset to set Elan to. And then you can just share the annotations and everybody can do that. Now, that was the student project by Liz Mahoney. So it was a sizable portion. I think we had like 17 videos on YouTube or something like that, which was already quite nice. And some were partially there. The problem is that's of course not replicable. You never know when YouTube is going to take that offline or somebody deletes their channel or whatever. So it's unstable and needs this exact time step matching, but it's a way around it. And another option is, of course, and Mark has already mentioned this, share annotations and derive data. So for instance, if you want to use it in machine learning, basically OpenPose Keypoints. So many of you have seen these things before. You have these keypoints for body pose, also face and hands, and then you give it an image and it basically finds these points through an algorithm, and then you can throw away the rest of the image and you're stuck with these kinds of things that are just data. And the good thing about this is then, again, any copyright information is gone. You can share like copyrighted information. It depends, of course, on the audio and the audio content. There's also some problems there. But if you want to like train machine learning, for instance, something like that, that's enough. And that's the last part of that presentation. This is Google Summer of Code Project 2021 by Swadesh Yana, who is, as I said, here in Zoom. So you basically take an input video and run OpenPose and have these key points. You arrange them in certain ways for machine learning and 3D arrays, and then it has this time series model from which it gives you a video and a CSV file. Now, these slides here are there to show you that they exist. If you are a machine learning person, you can ask questions about this. I can't explain them. But so Swadesh can explain them because he created them. So for us, I think the interesting part is what does it look like? And so I'll give you an example here. So what we did is we marked it in the video and get this structured CSV output. So for every frame, you get is there a gesture or not according to the system. And we also, there's going to be a little button here saying hand gesture detected. So let's play this. what you see is this and typical position for when there's a hand gesture going on are detected here, but sometimes you see that this blinks, so it actually missed something there. It says, no, there was no gesture. But overall, it's doing a quite good job, and we have some evaluations on that. So if you take just L interviews and you train on, like, I can't remember, I think it took 80% and trained on those videos, and then looked at the other 20%. Suarez says he got an accuracy of like 78%, which would be really, really nice. And precision 83%, that means in 83% of the cases when the computer says there is a gesture, it's true. And recall 77% means the computer finds only 77% of the gestures that actually are there in the video. So it misses like 23%. That's something you have to be aware of. And we, of course, wanted to know, does this actually transfer to other types of video? And the answer is yes. So this is the video that Mark just showed, and we just decided to use that too. And
he has in the channel, and his remote balance is my balance. So in every payment channel, there's two balances. Think of it as a pile of money sitting on one side of the channel and a pile of money sitting on the other side of the channel. When we open this channel between us, because I funded it into the multi-signature address for the transaction, the money is all sitting on.
Okay, you get the idea. Overall, this is actually pretty good. I mean, this is, again, a good recording, so it works better with higher resolution, but overall, that's what it does. So sorry, we're running out of time, and I just...
But read the paper where all this stuff is discussed.
And let me just say, due to lack of data, we can't actually predict at the moment which person is doing that, so we're just having that for the entire screen, and not just person by person. That's something we want to work on. We don't have any movement directions at the moment. There was not enough data to actually learn that from these annotations. And we're currently on this thing, we're inheriting the limitations from OpenPose. That includes wrist problems, for instance. Wrist is not missing if you don't see the elbow. And that is something that we're currently looking into. We are comparing, evaluating different pose estimation systems. And sorry for keeping you so long with all these issues. We thank you very much for your attention, and we're happy to take questions, probably in the discussion section later, because we're running out of time. Sorry for that.
So take it away.
Okay, so hello everyone. Thank you for having us in this awesome symposium. So Nikhil Mavelli and I will be presenting work that we developed together within the Google Summer of Code program in a collaboration between Red Hen and FrameNet Brazil. So I'll be starting the presentation, and then I'll give it to Nikhil to wrap it up. So the title of our presentation is Towards the Identification of Joint Meaning Construal, Language and Co-Speech Gestures on Focus. And the idea that we submitted to Google Summer of Code it started because both FrameNet Brazil and Red Hen investigate how meaning is construed in multimodal communication. On one hand, Red Hen has been focusing more on the relation between speech and co-speech gestures, while FrameNet Brazil, because it's a FrameNet, always looked into how frames are evoked by different communicative modalities, especially audio and video. So in a nutshell, what we wanted with this idea was to try to identify joint meaning construal patterns. And by construal in this proposal, we refer back to this definition presented in a paper by Sean Trott, myself, Nancy Chang, and Nathan Schneider from ACL 2020, where we propose, referring of course back to Langacker and Tolmie and all the cognitive linguists that have coined this term, that construal is a dynamic process of meaning construction in which speakers and hearers encode and decode respectively some intended meaning in a given communicative context. And to do so, they draw on their repertoire of linguistic and conceptual structures, composing and transforming them to build coherent interpretations consistent with the speaker's lexical, grammatical, and other expressive choices. So of course, in this definition, there is nothing new from someone coming from a cognitive linguistics perspective. But what this paper did, and the reason why it was in an ACL conference, was basically to come up with an incomplete taxonomy for the dimensions of Construal that could be used in computational applications. So such an incomplete taxonomy included prominence, resolution, metaphor, perspective, and configuration. So by prominence, we were referring to terminology like salience and profiling. So the cat is on the pillow is under the cat. For resolution, either the specificity or granularity, you could refer to a person as a person, a woman, an athlete, a figure ice skater, for example. Metaphor from cross-domain comparison, perspective taking to vantage point, and configuration when we look at internal structural properties of events and entities. So when we think about Construal, of course, we want to think, especially in this NLP-oriented or computational linguistics-oriented setting, does it really matter for daily unpretentious language use? So if we take this, of course, made up conversation between a person and a computational assistant, for example, like when is my 1-1 with Chuck? So the assistant answers 4 p.m. today in 15 minutes. And then the person can ask, is there another slot soon? And then not today, should I check tomorrow? And then the person says, let's push it to his tomorrow evening. And then rescheduled one-on-one with Chuck for 2 p.m. tomorrow, 6 p.m. in Brazil. So of course, this would be the perfect assistant. And the reason why it does not exist, and it would be perfect, is because this tiny dialogue involves lots of construal dimensions. So when the assistant answers 4 p.m. today in 15 minutes, the perspective dimension is brought into play because there is relative time. If you say another slot, you bring prominence into play because you must keep in mind the contrast with the current slot. And then expressions such as soon, today, and tomorrow set the resolution of this conversation to the calendric unit scale. Because, for example, if the assistant said, yeah, in 3 seconds, that would be soon, but not soon for this conversation. And let's push it. We have metaphor, the event as a physical object, and his tomorrow evening, you shift the perspective from the speaker to the person the meeting is going to be set up with. So if we push Construal into the multimodal domain, and we take, for example, the Flickr 30K dataset, which is a pretty popular multimodal dataset as an example, we can see that different crowd workers who produce the different captions in the Flickr 30K dataset. This is a dataset featuring a picture with 5 captions in English. It's being expanded to other languages, including Brazilian Portuguese. And then this same picture can be either defined as a woman figure ice skater in a blue costume, or a man and a woman ice skating on the rink, or you can have such as one of the Portuguese versions, woman skating on an ice track and a man also skating in the background. So you see that when you describe this image, you put different characters in prominence, you propose different vantage points when you are describing it. Also, you can vary the degrees of resolution. So for example, woman figure ice skater is more precise, more specific than a woman, for example, in this caption. But you're not here to listen about how this manifests in picture, but in gesture. So I'm handing it to Nikhil, who is going to explain to you how we moved from Construal to gesture communication.
I will now talk about how we can rely on gestures in addition to language, to identify construal dimensions. So one may ask, what's the motivation after all to study coarse-speech gestures? The knowledge of construals occurring in coarse-speech gestures can, help us in better downstream task performance, especially on tasks related to cross-modal translation, style transfer, and even grounded language understanding. Here, I want to point out two construal dimensions, which is most relevant to our work. The first one is perspective, which essentially states that the position of an object differs with respect to how an observer perceives it. The second one is prominence, which denotes how the importance level of different elements in a scene vary according to how the observer notices it. We only consider hand gestures for our study to limit the numerous kind of interpretations possible, like for different types of gestures, right, which can make the problem significantly complex, and also it can lead to spurious results. So in this slide, we enumerate different gesture types or attributes relating to hand gestures, along with their corresponding values to do our preliminary investigation. Our study uses the PATS dataset, which was a dataset released by researchers from CMU, and it's an acronym for Pose, Audio, Transcript, and Style. The Pose contains OpenPose features, which are available as 2D skeletal key points, whereas the audio contains features like log, mel spectrograms. It also contains word tokens, BERT embeddings, and word-to-vec embeddings from the transcript, which is the textual component. Here, I want to briefly point out the notion of lexical trigger and lexical context. Now, lexical trigger refers to the span boundaries of the text we want to obtain a corresponding gesture of, whereas lexical context denotes the larger segmented text with a predefined number of tokens to the left and right the lexical trigger is a part of. So now let's consider a sample video of a talk show host, Jimmy Fallon, again taken from the PATS dataset with a predefined start and end time. Now the video frame corresponding to the from to to lexical trigger for the anticipated hand gestures are shown on the right hand side. Now, as we can see, the lexical context here is travel from the US to Mexico by plane. And clearly, it is quite evident that the speaker has made a horizontal hand gesture movement from the right to the left when we compare frames 2 and 3. So frames like these constitute an example of a true positive instance. Now let's consider a sample video of a talk show host, Seth Meyers, again taken from the same PATS dataset with a predefined start and end time. Now the video frames corresponding to the from to lexical trigger for the unanticipated hand gestures are shown on the right hand side. And as we can see, the lexical context here is flight is from DC to Philadelphia, but it is quite evident that the speaker has made no gesture whatsoever when we compare frames 2 and 3. So frames like these constitute the true negative instance. So as we can kind of infer that merely relying on textual component of from to lexical trigger to identify the lexical to identify the hand gestures would not work in principle, because different speakers use gestures differently for the same lexical context. So hence we need to build a frame level hand gesture classification system, which is assisted by the lexical trigger. So to create the true positives and true negatives, we segment the video into video frames of equal time duration of 500 milliseconds. And then for creating the true positive instances, we extract the video frames corresponding to the start and end portions of the lexical trigger. And for the true negative instances, we extract the video frames and annotate those with hand gestures which are unrelated to the ones found in the true positive set. We use the popular transformer-based model to do the classification, and it contains several building blocks as shown in the slide. So to sum up, some of the potential future steps we can undertake is first we can use a open source frame semantic parsers, for example, Sling, Open Sesame, and so on, to extract the lexical units and also the frames that are invoked. So the idea is to capture the relationship between different semantic frames in a graphical form, such that the upper nodes contain shared properties, and the properties become more specific and less generic in the lower nodes. And also we can rely on annotation experts by supplying them with a questionnaire, and they can use true false statements to suggest whether this frame contained a gesture or not. So with that, I would like to conclude our presentation, and thank you all for listening.
So today, well, we're going to start with qualitative work, how to generate a hypothesis. That is nothing new, that it's just everybody is doing that here. But the interesting part might be then how to scale it up and try to find similar instances of co-speech gesture in a larger corpus. Will start emerging. And that was the target that we were looking for. And then you can just click this one for the next concordance line if you want.
Every single culture on Earth has prohibitions against killing. At the same time, virtually every culture on Earth will reward you enormously.
And you see these are automatically created captions for YouTube enormously, but Will actually works out quite well. And so we were able to find this. Now, we can actually, if we want to use the computer vision systems like OpenPose that we showed earlier, we have that coded into that search engine so that we can look for, in the more complicated syntax, it's called the CPP syntax, we can say we're looking for a word where the lemma is will, so all forms of will. And at the same time, on this word, there should be a wrist visible at least. So we know we see the hands in this video. And because the ones that you just saw didn't have any hands in there, we were not interested. And it was the wrong guy anyway. We were interested in the artist.
very much like Oscarina and beauty.
So I know that you once said an architect should be able to understand what is happening now and predict what kind of architecture people will need in the future.
Yeah, so there was the word will, and there were lists on the screen. Now the issue is, of course, this was 19. We then said not only during the word, but during the entire shot, we want to have it, and that's how we got the 84. But if you say, whichever way, you can take these 19, these 84, or you can say, no, I don't trust the computer, I want to do it myself. Then you download these 750 matches, and it gives you, we have this special button here, download for Rapid Annotator, that does exactly that. It's basically a text table format that has the video links in there, and then you can take it to the Rapid Annotator and set up an experiment. I already did that because it takes like a few minutes. So let me just pause here, and what you set up is like the kinds of questions you ask. So here I'm asking two questions. Is this Sophie? That's the host we're interested in. And the second one is, can you see your hands? And it will only show the second question if you answer yes to the first.
Virtually every culture on Earth will reward you.
And what we do is basically every time we see it's not Sophie, when Will is uttered, we hit no, or a key number 2 on the keyboard, or no on the cups. And it will immediately load the next video. They're already preloaded in the background. Now I hit yes, because this is she's speaking, but now we don't have hands. And then video, I set it to 2 seconds to the left and right. It will loop in the background forever. So it will just go until you hit these keys. You can, of course, pause it if you want. So that's, I think that's where the video should stop. Yes. And so with a Rapid Annotator, you can then go back as the experiment, and you can set this up to basically allow other people to annotate together with you. And then you go to view results. And now I'm looking at the results for myself because I coded these things just a few seconds ago. And you see that I have lots of no's, and then I have some yes, and here we can see the hands. And you can download that as an Excel file sheet, spreadsheet, and just use it in Excel to download only the videos that you're interested in. And that is when you then give them back to the people doing the qualitative work. Mark, did you just hit something here? I hope not. Okay, well, no matter. And that's where Anna comes in again.
So one thing I wanted to add, that we also use this wonderful comments box, yes, to edit a caption if we needed to, because obviously the automatic system could give you spelling errors, and also to mark where gesture fault, so fell. Okay, so as a result of our annotation in the Rapid Annotator, out of 84 snippets, we then had 47 video snippets for Symposium speaking and gesticulating, that's the host. And after we've done our subsequent analysis of the results and had our preliminary theory of what speech gesture arrangements make artistic or visionary shows different, we needed to test our theory by comparing the results, those results to results of analysis of other propaganda and non-propaganda shows in which we have Symposium speaking and gesticulating. The image of this spreadsheet, which you see here, is an illustration of our analysis of 86 video snippets, and that would be for 2 languages, English and Russian. Since Symposium speaks multiple languages, and 2 of which are she speaks as native languages, we analyze her speech gestural behavior in English, Russian, and Georgian language shows. For Georgian, we did annotation analysis of the depictions of futures using Elan in addition to the Rapid Annotator. That was 8 videos. For English and Russian, we've now also added the analysis of prosody. So our preliminary findings include establishing a certain type of distribution of an interaction between gestural and prosodic phrases as a distinctive feature of manipulation in IT shows. We're currently testing our theory by doing more precise annotation for speech, prosody, and gesture of those 47 video snippets from Symposium visionary shows using Pratt and Elan again. This is a rather time-consuming and labor-intensive endeavor, as you all know, and it has highlighted a need to introduce new features, new analysis, which we would like to achieve.
And that's where I come in again. So how can we basically work with all this? So about this computer vision pipeline and rapid annotated thing, you have to understand it's work in progress. We have this research project where we use this in the methodologies, work packages, and we're trying to get there. We're now hiring a computer vision expert full-time to help us with that. And the question is, of course, and that's one of the reasons why we're here, is to understand what does the community actually need. So what kinds of annotations do you need on these videos? What kinds of features would you like to see both in the query system and in the annotation system? And that, of course, relates a lot to what kind of questions would you like to ask. Basically, for the Rapid Annotator, we now have another student for this Google Summer of Code, same as last year, Mohammed Mokhtar, and he's doing, now, at the request of Anna, we've already put in, last year, we put in additional comment boxes, additional ways of, as she said, changing the captions. And now we're looking at things like time-based annotation, frame-based or something like that. Can we find a way that is both exact and fast? That is the interesting question, because this is really fast. You can get through like 500 videos in 2 hours by just saying a few things like yes, no, yes, no, yes, no. For classification, that's perfect. But if you want to go into the nitty-gritty, it doesn't help. And we want to be able to do at least some of that. And the interesting thing is, what are the features that you actually need? And we're very much interested in your feedback throughout this conference to learn about this. And so tell us now, tell us later, or drop us a line. I would like to acknowledge also that we have had generous funding, mainly from the AHRC and the DFG, but also many others. And we're very grateful to our helpers, research team, everybody here, people we can talk to and ask for advice. If you want to know more about that research, go to imcc.web.arcs.ac.uk. That's the International Multimodal Communication Center, which was founded by Anna, Scott Hale, our co-author, who's not here today, and Philip Tor from Computer Vision is another co-director.
Yes.
Okay, thank you very much for your attention. Sorry for keeping you longer than expected.
Throw it away.
No. Where? That's really what I want to say. So I was very excited by the topic and the bringing of data science to gesture studies. But I've seen this before. This connection between sort of the more technological side of what we can do with language-related data and where we are, I guess, on the linguistic side. And we're not, I don't know, I don't want to say we're at a crossroads because I'm actually extremely buoyed and happy at the beginnings of, you know, an interaction between technology and what we might just call old-fashioned language analysis. But it's not even old-fashioned language analysis. So, you know, I feel like there's going to be there's a lot of laddering going on in, should we say, the more computational side of humanities work. You know, it's language, it's humans. And there's been a real sea change over the last 20, 30 years in linguistics. I'm a linguist, so that's going to be my my starting point. But you know, the advent of usage-based approaches in cognitive and construction grammar, marrying work in multimodality and gesture studies, and there's sort of another marriage. This is sounding pretty wild, like a polygamy. Yes, we're polygamists, all of us, in our, we're open-minded, whatever. But the whole idea of corpus, a corpus, a queryable corpus, and concordance tools, right? So that's been, at least on the monomodal side of language analysis, it's been a very, very exciting thing. But it seems to kind of have stalled in places. And I think I would hate to see multimodality studies, because I know you like to use the word multimodal theory or multimodal science. I'm afraid we're not really there yet, but maybe we will be there very, very soon. And I don't think we should ever actually be there, in the sense that we're not talking about predictive behaviors. We're talking about a set of very robust correlations that are not obligatory, that they're not arbitrary. They bring in multiple variation. I mean, the signals, the multiple channels that we're trying to correlate with meaning making in an interactional setting, that's a really tall order. We're looking at the speech signal. I'll just leave sign away for a second. But even like simple spoken language corpora don't always do a very good job with prosody. So there's part of that signal is missing. And not to be a killjoy, but there was something very interesting in all four talks. There was always just like one body part or one part of the signal that was being sort of focused on. So a word and the wrist, or not the face, or the skeleton, but really no hands, or just handshake. So there was a kind of a disjunction between what most of us in the room that aren't, that are looking maybe more qualitatively, more anecdotally, looking at smaller data sets. I do appreciate the push toward bigger shareable data, no question about it. But we're looking at the confluence of many channels working together in the signal. And the signal, I was going to ask you how long your vector was, you know?
Long.
One
really
frame.
Long.
I mean, is
one
it?
frame. You saw one, what you saw was key points for one frame.
One frame.
Yeah, but The computer doesn't care how many numbers there are.
How many you stack up, right? And we're increasingly, I mean, so the tyranny of structuralism, all of us probably in this room are fighting very, very hard to get beyond sort of traditional morphosyntax. But we know that prosody and embodiment and stamps are all elements that go into what we consider important in language. So multimodality is a very big thing when you bite it off and try to chew it. And I appreciate that you kind of have to nibble at it from various sides. And I absolutely admire the push towards shareability, replicability, rapid annotation, or just searchability of a pre-existent database. When I think about the massive advances that child language studies made with Brian McWhinney's push of Childus as a sharing archive. But then I also think, yeah, and how many people really use chat and plan? You know, it's always a lot of bespoke coding that, sort of the lowest bar is to just convince our monomodal colleagues that language is far more fulsome than they ever really think about, because that's really hard to think about all of those elements that go into the signal, the meaning-making signal. I'm not sure where I was going with my the second part of that comment, but we, you know, I feel like we're really on the cusp. We really have to spend effort developing what we mean by multimodality, what we mean by testable theory, you know, and I'm not even sure. I mean, I appreciated very much your examples with two different genres, I guess, propaganda and non-propaganda, but I was trying to think, how could I frame a hypothesis about that, and what would it mean? Or even, Peter, no disrespect, just looking for positive instances of gesture when non-positive, negative instances are also really interesting, right? So, you know, that may be too much of a filter to put on, but I know that you can also search for it.
No, we actually do that that's why we ask for wrists. Yeah. So wrist visible is actually, so we can see, is there a gesture or not? Is
there a potential and did it happen?
Because if you don't see the wrist, then often it's actually, I mean, in media, it's not always true. Sometimes you get the hands moving up into the frame when people gesture, but normally if you don't see the wrists, then you can't get gesture. And if you look for anything where there's a wrist, then you can count, is there gesture or not? So that's possible.
So and my final comment, I'll attack Mark, no. But you know, I appreciate I appreciate so much, you know, the summer school idea where you're really trying to target the problem. You know, if I thought of all of that computational ability and prowess and results, if that could be put into a really strong concordancer that could look for multiple parts of that Elan tier at the same time, could lematize gestures. I mean, that's a kind of a weird idea, but it's something that we're going to kind of need. I mean, even maybe open hand would be sufficient, whether it's, you know, what direction. But also, I mean, since we're really interested in larger swaths of discourse and what's going on with multiple speakers, because that's where language is, after all, we really would like to know, we'd like to be able to pull out collocations of gesture speech, you know, so thinking about like an engram that's a lexical bodily bundle. That's what would be really, really cool. And the final comment is, we're a very disparate set, all having that common, I don't want to say adherence, but a common belief that language is a multimodal enterprise. We come from different disciplines: psychology, linguistics, anthropology, computing science, business. And there are different technologies, different associated with these different disciplines that most of us never get around to learning. I would love to see ISGS perhaps or Red Hen support some intensive summer schools that were multidisciplinarian, or that kids, it's my age, were paired up with an expert in another area. So you had like an expert annotator. Actually, even Elan annotation is not taught in classrooms very often, or the idea of a class or course in multimodality not taught very often. So that's where our colleagues in data science are far ahead of us, because they can gnaw on any kind of problem. But on the sort of non-technical side, we have, I feel like we're all getting an idea that we're on the cusp of some major breakthroughs that folks like, our symposium organizers have been pushing for years. But now it's time to sort of bring the different communities back together in a very, very strategic way. So I appreciate very much, Peter, your call for ideas, or give us your coding problems. Well, I'll be in touch. But I feel very, very hopeful as a sort of a sometimes cognitive linguist, sometimes corpus linguist, sometimes multimodal person. It's very encouraging to see the confluence of these various strains. So let's braid it into a real strong thread. Okay, thank you.